power amplifier. Now in previous topics we have studied about the different types of amplifier. Now these amplifiers are related to voltage. That means these are the different types of voltage type amplifier in which the power level is very small. When in power amplifier the power level is very high. So in last stage of radio receiver coil of a loudspeaker moves accordingly to the magnitude of the signal and the frequency which moves the cone of the paper cone of the loudspeaker, and then this signal is converted into sound. So now therefore sufficient amount of current passing through the coil of the loudspeaker. Now therefore power amplifier is used. So you can say that power amplifier is an electronics device is designed to convert low power signal into the high power signal. And next, what is the difference between voltage amplifier and a power amplifier? So now first basic. So now the main difference between this voltage amplifier and power amplifier. So in voltage amplifier it increase in voltage level, and in power amplifier it provides increase in the power level. Next, which type transistor is used? So now in voltage amplifier transistor chosen should have a higher value beta about 100. Now in power amplifier transistor should have a small value of beta about 20 to 50. Now the base region in the transistor. So now in voltage amplifier the base region is thin. Now in power amplifier comparatively it is thicker than the voltage amplifier. Now collector circuit resistance. Now voltage amplifier the collector resistance value is very high. So it is between 4 kilo ohm to 10 kilo ohm. In power amplifier its value is low and it is lies between 5 ohm to 20 ohm. Now next, the heat dissipation, it is also most important factor. So in voltage amplifier heat dissipation is less, while in power amplifier it is more. Now which type coupling used? In voltage amplifier RC type coupling is used, while in power amplifier transformer coupling or tune circuit is used for the coupling. Now the input voltage, the value of input voltage in voltage amplifier is very low and its value approximately a few milliwatt, while in power amplifier the input voltage signal it is also high and its value about a few voltage. Next, collector current. That we call a collector current passing through the transistor. Now in voltage amplifier its collector current is very low and its value about 1 milliampere, while in power amplifier the collector current value is high and it is 100 milliampere or greater than 100 milliampere. Now the output power output. So in voltage amplifier output power it is low and it is in milliwatt, while in power amplifier it is high and it is taken into watt. Voltage gain, the voltage gain of voltage amplifier is high and in power amplifier it is less. Current gain, in voltage amplifier current gain is medium and power gain it is less. The power gain in voltage amplifier is less and in power amplifier it is higher. Now the output impedance of this amplifier. So now output impedance of the voltage amplifier it is high and it is in kilo ohm, while in power amplifier it is low and its value it is in ohm. Now, what are the uses of this amplifier? So now, voltage amplifier, it is used in initial stage of the amplifier. Now, power amplifier, it is used in middle and last stage of the circuit. Classification of power amplifier. According to the operating point Q on the DC load line and the collector current conducted through the period are classified in can be classified in four ways. First, class A amplifier. Second, class B amplifier. Third, class AB amplifier, and fourth, class C amplifier. Now, first, class A amplifier. Now, in this type of amplifier, the operating point Q should be kept in the middle of this active region. So the transistor no driven into the cutoff region or the saturation region, and the collector current conducted through the total input cycle, that means 0 to 360 degree. But the efficiency of this transformer is less because the collector current ICQ is flowing from the supply, even the input signal is 0. So now, due to this reason, this amplifier is not used in power amplifier. Now, in this amplifier, the distortion is less, but it is a non-linear distortion. Now, second, class B amplifier. Now, in this class B type amplifier, the biasing of transistor should be selected in such a that the operating point Q on the DC load line becomes on the cutoff. So, the collector currents conduct to the only positive cycle. So that means it is operated in up to 0 to 180 degree period. So here collector current is only flowing during the positive cycle. Now, during this negative cycle, there is no collector current flowing through the circuit. Even your input signal is 0. So that's why the efficiency of this class B amplifier is high. Now, here in this class B amplifier, no even harmonics is present. Class AB amplifier. Now, in class AB amplifier, the operating point Q of the transistor is kept nearer to cutoff. So, the collector current flows from greater than 180 degree and less than 360 degree. So, you can say that the collector current flows during the positive half cycles and the clippings in the negative half cycles. So you can say that your collector current is flow from 180 degree to 360 degree. Now, the efficiency of this transformer, it is between class A and class B amplifier. So now there is a distortion occurs in the output. Now next, class C type amplifier. Now in this class C type amplifier, the operating point Q of this transistor is beyond the cutoff region. So now the conduction period of this class C amplifier is less than 180 degree. So you can say that your collector current flows during the positive half cycle, but its duration is less than 180 degree. So now the reduction of this the collector currents, which increase the efficiency of this amplifier, which is approximately theoretically around 90%. But due to the reduction in conduction period causes a lots of distortion in the output. So now it is used in the last stage of the radio transmitter.